I wanted to work through an example that involves applying the laws of motion, specifically the second law of motion. So in this example, we're imagining a bullet that's fired from a gun, and we're told that the mass of the bullet is 5 kilograms. We're told that the speed that the bullet leaves the gun at is 308 meters per second. And we're told that the length of the barrel of the gun is 0.78 meters. And we're asked to imagine that the bullet is accelerated from rest to 308 meters per second along the length of the barrel, 0.78 meters, by a constant force. Now, I'm sure a bullet fired from a gun isn't accelerated along the length of the barrel at constant force, but we're going to approximate the bullet being accelerated along the length of the barrel of the gun by a constant force. And we're going to figure out what that constant or that average force is. To solve this problem, I'm going to start by sketching the motion of the bullet along the length of the barrel and annotating the sketch with the quantities I know about the bullet's motion along the length of the barrel. And then that'll lead me into the calculation. And the calculation is going to involve 2 steps. So one step, we're going to think about the kinematics of the bullet's motion along the barrel, and we're going to calculate its acceleration. And then the second step, we're going to think about the dynamics and the force that's propelling the bullet down the length of the barrel. And so we're going to be combining some work from earlier classes on kinematics and equations of motion with work from this class on dynamics and Newton's laws. And that's often the case in problems involving forces and motion, that we're combining our understanding of kinematics and dynamics. Okay, so let me start with a sketch. Here's the bullet traveling along the length of the gun. It's the bullet traveling down the barrel of the gun. The bullet's mass is 5 grams, which is 5 times 10 to the minus 3 kilograms, because 1,000 grams in a kilogram. The bullet starts out at rest, and so V naught is 0, and the bullet reaches a speed of 308 meters per second. The bullet is traveling a distance that is the length of the barrel, that is 0.78 meters. And we want to first figure out the acceleration, which is in the direction of motion because the bullet is speeding up. And then we want to figure out the mass of the force on the bullet, which is also in the direction of motion because the bullet is speeding up. So we're going to start with the kinematics part. And try and figure the acceleration. So in figuring the acceleration, I think back to the equations of motion. I think back to the quantities I know in this problem: initial, final speeds, and distance traveled. And the quantity I want the acceleration. And I'm led to the following equation of motion. It relates the initial and final speeds to the displacement and the acceleration. And if you look at this equation, well, we know the initial speed was 0. We know the final speed. We know the displacement. The only thing we don't know is the acceleration, and we can calculate the acceleration, therefore, using this equation. So if I rearrange this equation for the acceleration is going to be the square of the final velocity divided by 2 times the displacement. And the final velocity is 308 meters per second. And that's going to be squared. And then the displacement is 0.78 meters. And that's got to be multiplied by 2. And so if we carry out that calculation, let me do it quickly on my calculator, it comes out to be 6.1 times 10 to the 4 meters per second squared. That's an acceleration. Now, if you want to think about that acceleration, you know, is it big, is it small? Think about the acceleration of gravity, 9.8 meters per second squared. That's roughly 10 meters per second squared. This is almost approaching the scale of a 10,000 times that acceleration. So this is a huge acceleration. Anyway, now we know the acceleration, we can apply dynamics to figure out the force that must have been acting on the bullet as it travels down the length of the barrel. And that force is determined, in this case, by the acceleration and the mass of the bullet, according to Newton's second law. So this force is the force that will create this acceleration. We know the mass of the bullet, 0.005 kilograms. And we know the acceleration, 6.1 times 10 to the 4 meters per second squared. And so we can multiply those two numbers to get the force. Comes out to be 304 newtons, or kilograms meters per second squared. And so that's the solution to this problem. Again, just to summarize, it's a problem that had 2 steps, one involving kinematics and one involving dynamics. In the kinematics step, we answer the question, what is the acceleration? In the dynamic step, we answer the question, what is the force? In the kinematic step, we used equations of motion that allowed us to figure the acceleration from the known initial and final velocities and distance traveled. And then for the dynamic step, we used Newton's laws. We used the second law of motion, which tells us how accelerations are caused by forces. Forces acting create accelerations. Anyway, that's a simple example of the laws of motion and the relationship between forces and changes in motion. And over the next week or so, we're going to be looking at more sophisticated, more complicated examples involving forces in motion.